Hi there, this is Regina. In this video, I want to discuss how Educational Testing Center will question your knowledge on roots. A quick review. If you see something like this with a number here, that is a square root. If you see something like this, that's a cube root, and I know you know this already. Just want to remind you on how to convert the radicals into fractional exponents. If you have cube root of a number raised to another number, say 2, you can also write this as a to the power 2/3. That's one way of removing the radical symbol here. Let's go through some facts here. Fact 1, when you're adding and subtracting square roots, you must add and subtract only the like roots. For example, you can add root 3 and root 3 to make it 2 root 3. Or root 3 minus 5 root 3 can be negative 4 root 3. But you can never add root 3 plus root 5. This is already simplified. Fact 2. To simplify square root, factor as you would normally factor, keeping one of the factors as a perfect square. Let me explain this to you. So if you're trying to simplify 27, you would want to use one of the factors which is a perfect square, such as a 9. So root 9 times root 3 gives you root 27. And the reason for using a perfect square is that you can turn that into a nice integer number. To simplify root 12, I would choose to use a root 4 and a root 3 because I can simplify 4 as a 2 root 3. I will not do 6 and a 2. Neither 6 nor 2 is a perfect square. So what this means to us is that if you had a problem which was root 27 plus 5 root 12, and you notice that they're not like radicals here, you can simplify them as I've shown above and convert it to 3 root 3 plus, and this one will turn into 5 times 2 root 3, which will become 10 root 3, and your final answer will be 13 root 3. So now you can add them. For multiplication and division, you multiply and divide as you would normally. So root 7 times root 2 is equal to root 14. Or root 14 divided by root 7 will simply be root 2. Let's look at a combined operation here. What if you get 2 root 2 plus 4 root 18 divided by root 2? You can rewrite the problem as 2 root 2 over root 2 plus, and if you simplified root 18, that becomes root 9 times root 2, which is 3 root 2. So if you change this to 3 root 2, you will have 12 root 2 over root 2. If you separated them as two separate fractions, you can actually cancel the radicals here. And your final answer is 2 plus 12, which is 14. Let's go ahead and look at another problem. 6m times n square root of 10n divided by 3n root 5. So we can reduce root 10 over root 5 to root 2. So 6 and 3 will reduce. The n's will of course cancel out. You have twice m root 2 n. And that's your final answer. So I now want to try some SAT type questions. Here's the first question. The square root of a certain number is twice the number itself. What is the number? So let's go ahead and translate this. The square root of some number you don't know is twice that number. You can square both sides to get rid of the square root. Square both sides. And what you have is x is equal to 4x squared. Just remember that converting the square root into a fractional exponent is x to the half. And if I squared x to the half squared, you will agree that this is x to the 1. So that's why when you square the square root, you get that number back. All right, so now we can bring all the x terms to one side, factor the x out, so you will have 4x minus 1 is equal to 0. So you can tell that x could be 0, and if 4x minus 1 is equal to 0, then you can solve for x as 1 over 4. So x could be 1 over 4. Okay, this next question is a little tricky. If half x is less than square root of x, which is less than x, then what could x be? The best way to handle this is by trial and error. You know that you can never square root a negative number, so the x values are positive or greater than 0. The easiest perfect square that I can think of is x equals 4. So let me test x equals 4. So if x is equal to 4, half of 4 is going to be 2, and square root of 4 is 2, and this one we decided was 4. So this piece of inequality is okay, but it violates here. It doesn't work. Now the next one is x equals 1. Actually, I should have picked 1 before. So if x is 1, the square root of x is 1, and half of 1 is a half. So this works. This piece of inequality works, but here 1 is not less than 1. So we have anywhere between 1 and 4 that should work. So if I were to do a number line, and I know that 1 does not work, 4 does not work, all I need to do is pick a number here, pick a number here, and pick a number here, and then whichever one works. So let me try picking a half. So if x is equal to half, half of a half is a quarter. Square root of a half, and I can do that on my calculator, square root of a half is 0.707, so that works. 0.25 is indeed less than 0.707, but that is not less than a half. So it's not this region here. What if I picked a 3 or a 2? So if x is 2, square root of 2 is 1.4, and that inequality works. 1.4, and that does work. And a half of 2 is 1, so the inequality holds. So this is a yes region. What if I picked a number larger than 4, let's say 9? If x is equal to 9, then square root of 9 is 3, and 3 is indeed less than 9, but half of 9 is 4.5, which is not less than 3. So this is no. This is not my region. So the answer lies anywhere between 1 and 4. So 1 is less than x, less than 4, remembering not to include 1 and 4. So here I've shown you how trial and error can get you the correct answer. Okay, moving forward, I would like you to pause the video and try these problems on your own. Okay, so the first one, a squared plus 1 equals 10, b squared minus 1 equals 15. What is the greatest possible value of a minus b? In other words, what is the difference between the two values? Now I hope you noticed that a squared is equal to 9, which means a is plus or minus 3. And if b squared minus 1 is 15, then b squared is 16. You add 1 to both sides. So b is plus or minus 4. So what is the greatest possible distance between the two? So you could have either negative 3 or positive 3 as your answer, or positive 4 or negative 4 as your answer. And you can see that the greatest possible distance would be 7. And the answer is 7. So I hope you got E as your correct answer. Let's try this one here. Notice that they're not asking for y but y cubed. Let's remove the radical, square both sides, and you'll end up with 9y squared is equal to 2 over y. So if you multiplied both sides by y, you'll get 9y cubed is equal to 2. Solving for y cubed, your answer is 2 over 9. So did you get A? Next one. A rectangle has sides of length root A and root B. So let's go ahead and sketch out a rectangle. And the sides are root A and root B. And the question is, what is the length of the diagonal? And you know that the corners of a rectangle are 90 degrees. So this is Pythagoras' theorem, root A squared plus root B squared is equal to the diagonal squared. Let's just call it a C here. So it's root A squared is A, root B squared is B, is equal to C squared. And if you square root both sides, it is very important to understand that you'll be squaring A plus B like that, not separately. So your answer should be C and not A. If m and n are both positive, then which of the following is equivalent? So I can almost tell right away that I will be canceling that. I can almost tell right away that root 18 will turn into root 9 times root 2, which is 3 root 2. So I'm going to rewrite my question as 2, 3 root 2 root n over root 2. The root 2 is canceled out. And my final answer is 6 root n. And the answer is D. I'd like to revisit this question here. The area of a square A is 10 times the area of square B. So if you have your square A, and this is your square B, and this is 10 times. So if I assume that the area is 1 here, the area here would be 10, and the sides would be root 10 each way because it's a square, and the sides would be 1, 1, and 1. And the question is the ratio of the parameters. So the parameter of the larger square is 4 root 10. The parameter here is actually 4, so the ratio is 4 root 10 to 4. And if you simplify this, it is root 10 to 1. And the answer is C, not D as was shown before. Okay, that ends the session. Thank you very much for listening. Goodbye.